Day 16, back to the stream. Yesterday was a late night. I'm feeling a little tired today, so hopefully, this won't be too bad. All right. Transmission to site using the bits. Submarine's transmission is in hexadecimal. Okay. Bits transmission is a single packet outermost layer, which itself contains many of the packets. The hexadecimal representation of this packet might encode a few other bits as zeros at the end. These are not part of the transmission. Every packet begins with a standard header. The first 3 bits encode the packet version. The next 3 bits encode the packet type ID. These 2 values are numbers. All numbers encoded in any packet are represented as binary with the most significant bit first. Okay. Packets with type ID 4 represent a literal value. Literal values encode single binary number. To do this, the binary number is padded with leading zeros until its length is a multiple of 4 bits, and then it is broken into groups of 4 bits. Each group is prefixed by a 1 bit, except the last group, which is prefixed by a 0 bit. Groups of 5 bits immediately follow the packet header. For example, the hexadecimal string D2FE28 becomes that. What? Okay. So, packet version 6, packet type 4, 5 bits, start with a 1, so it's not the last with 4 bits. Not the last with 4 bits, not the last, yes, the last with 4 bits. 3 unlabeled 0 bits, blah, blah, blah. Every other type of packet, a packet with a type ID other than 4 represents an operator that performs some calculation on one or more subpackets contained within. Right now, the specific operations aren't important. Focus on parsing the hierarchy of subpackets. An operator packet contains 1 or more packets. To indicate which subsequent binary data represents its subpackets, an operator packet can use one of 2 modes to indicated by the bit immediately after the packet header. This is called the length type ID. Length type ID is 0, then the next 15 bits are a number that represent the total length in bits of the subpackets contained in this packet. If the length type ID is 1, then the next 11 bits are a number that represents the number of subpackets immediately contained in this packet. Finally, after the length type ID bit and 15 or 11 bit field, the subpackets appear. For example, here's an operator packet, 38 blah 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 blah. Type ID 0 that contains 2 subpackets. So the 3 bits V are the packet version. Have we talked about what version actually means? We have not said anything about what version is important for. Okay. So version 1, packet type 6, which means it's an operator. The bit labeled I is 0. The length type ID indicates that the length is a 15-bit number representing the number of bits in the subpackets. The 15 bits labeled L contain the length of the subpacket in bits, 27. The 11 bits labeled A contain the first subpacket, a literal value representing the number 10. 16 bits labeled B contain a second subpacket, literal. After reading 11 and 16 bits of packet data, I don't understand why we have 11 and 16 bits. Total length indicated is 27, so the parsing stops. Another example. What? Length type ID that contains 3 subpackets. So the version is 7, the type is 3, which means it's an operator. The I is 1, indicates the length is an 11-bit number representing the number of subpackets. The 11-bit number contains the number of subpackets 3. 11 bits contain the first, 11 bits contain the second, 11 bits contain the third. After reading 3 complete subpackets, the number of subpackets indicated in L is reached. So the parsing of this packet stops. For now, parse the hierarchy of packets throughout the transmission and add up all the version numbers. Seriously? Add up all the version numbers. What does the puzzle input actually look like? Just a giant string of hexadecimal. Okay. So we weren't given one sample, we were given 7 samples. Or several, not 7. Several samples. Okay. Let's see if we can understand this. So, first 6 bits are always version and type ID. 2 values of numbers. All numbers encoded in any packet are represented as binary with the most significant bit first. Example, version encoded. Okay. 4 is a literal value. Literal value packets encode a single binary number. Do this, the binary number is patterned leading zeros until its length is a multiple of 4 bits, and then it is broken into a group of 4 bits. So for example, that becomes that. I guess that's our first input. No, I don't need a new version of Go, please. Thank you. Where's my Help tab? Why is my Help tab not working? Okay. Packet is okay. So the hexadecimal representation of this packet might encode a few extra zeros. These are not part transition, should be ignored. Single packet at the outermost layer. So as near as I can tell, each one of these examples has padding in them, but there's only padding at the very end. So you really have to treat this as a string of bits. You can't treat it as a string of hex. So the very first thing we obviously have to do is convert it to a string of bits. Line, select. That's going to be a C, right? That's going to be a char. So toString. We really want these to be bits. Easiest thing to just set them as a bunch of bools. I don't know. Let's say x2 bools. Yeah, let's just parse the whole line. Try not to cut it up. So we're going to say we're going to give you back a Boolean array, right? Parse line, string, line. For each, let's see. So the result is going to be a new Boolean array. We get 4 bits out of every character. So line.length times 4. Index is 0, index is line length. Alright, because we're going to index into the result array as well. Yes, I know. What we want is line of index There is like a binary encoding. Apparently not for char. Thought there was an easy way to do this. Convert char to bits. C#. Convert hex char. It's byte value. Convert to int32? I don't really want the int value. Convert to I want to convert binary. For small strings with 14 characters not work because the result is too large, because you can't do it. Sure. So I suppose I could do this. Alright. I had a hex string. So 2 int32 of a hex string. This is clearly the least efficient way to do this. All right, that's going to get me a string back for each char, for each bit. If bit is equal to 0, then okay, we need a result index as well. Result index double plus is false. Actually, they're probably false already to begin with. All right. Line is not null. Constant value is expected. Why is that a constant value expected? Because I did that? Okay. So data is going to be that. We'll just do single. So we get back one Boolean array. Let's see how this looks. All right, D2 FE is looks like 110 110 110 110 100 110 110 D. So that's D. That's 2. Okay, F should not be 0, 0. What the hell? F should be 1, 1. What am I missing here? Did I go backwards? I must have gone backwards, right? 1, 2, 3, 4, 5, 6, 7, 8. No, all right, fine. Can't believe I screwed up something so simple. Oh, what are you waiting for? All right, so we've got a D. You know what? that, please. One 1101. 1101. Okay, that's a 1. That's a 2, sorry. You're not long enough. That's the problem. You need to be padded out with zeros. So this convert to string base 2. So you need to be pad left. I don't know why. I don't know why OmniSharp is such a piece of crap. Can't ever remember. Like, yeah. Oh, I have to analyze 15 projects. Oh, dear Lord. Shut up, shut up, shut up, shut up, shut up. I don't even know why I bothered reloading it. Thanks for the good times, OmniSharp. Fuck this. What is the point of waiting? Kill that terminal. Pad left, total width, and the padding character. Okay. 4 zeros. I don't know why I ran it. Running isn't going to do anything. I need to look at the data. All right. 1101 0010. 1101 0010. Good enough. All right, there's some bits. Okay. Okay, so while true. Alright, we'll start at 0. So while index is all true. Let's see. Conversion is going to be, I also need a result here, right? So return the results. So the version is going to be, let's see. You know what? Instead of being an array of bools, this should be an array of bits, shouldn't it? This should just be a string. Our result is a new string builder. That should just be result, append this. And then you don't need to be a temporary variable, you can do that. You don't need an index. String builder needs a namespace. And we'll return the toString of the string builder. Alright, so now this is a string. Alright. Let's go ahead and do that. One 1101 0010 1101 0010. Okay, looks good. So all true. Version is going to be int parse of let's see, data index, shut up, Stop it. Index plus 3. Why? Really? Okay. Right, and you need to be told the radix. So parse a string, number style, number style, number styles. Number styles. Binary. Okay. So you'll do hexes and integers, but you won't do binary, really? Why did I even stay awake for this? C#, parse, binary string. Convert to int32, not int parse. Convert to int32 of format provider. Format provider. Literally says you can pass the number 2. How is the number 2 a format provider? Right. Of course, there's something else. There's another overload. There's 18 overloads. Why wouldn't there be? Alright, I just want to see this one version. Just to make sure this is doing its thing. Yeah, I don't need you anymore. Version 6. That's what it says. Version 6. Okay, then I need a type. Type is convert to int32 data of index plus 3 to, God bless America, comma 2. Alright, that's gonna work. Why not? Version type. Okay. Type represents a literal value. Okay, so if type is 4, we do literal value, otherwise we do that. So we know that we should stop when index is greater than or equal to data length minus 6. I think. Here's 0 and the length is 6. Yeah, that should be fine. So if the type is 4, all right, then we say index plus equals 6. So if the type is 4, what we want to do is we want to say while true, first bit is going to be data of the next index. If the first bit is 0, then we break, right? Because it starts with a 1, it's not the last group. Then the next 4 numbers are a number. The next four numbers are a number, right? Value. Yeah, we actually don't care, right? Should extract value here. Don't care about that yet. Index plus equals 5. You skip over 5 bits. And then you return the result. So this one, because this data is only a 4, we should get its one version being 6. Except we didn't even get that because we forgot to record the version. Help if you did less than or equal to instead of greater than or equal to. An index out of bounds, that's fantastic. Let's find out why. Index is 0, so there we got version 6. We got a result of 6. We've got a type of 4. If the type is 4, while true, we grab the first bit, it's a 1. We move forward. Grab the next bit, it's a 1. We move forward, we grab the next bit, it's a 1. We move forward. How did we end up? Oh, we already moved forward 1 here. We only moved forward 4, dummy. Okay. Yep, so there's our 6. So then the other one is, we're given this. Length type ID 0 contains 2 subpackets. Well, we don't know what the hell that means. 2 subpackets. All right, let's do that then. So we get version 1, we get type 6. Bit labeled I, 0 is the length type ID. So we need a length type. Our length type is data of index plus plus. Length type is 0. The next 15 bits are a number that represents the total length in bits of the subpackets contained by this packet. Okay. Length type is 0. So this one's going to have a 0. That the length is a 15-bit number representing the number of bits in the subpacket. Fine. Our length is convert to 32 of data index to index plus 15. All right. And then we move forward. And you're binary. Make sure we're seeing that correctly. Oh yeah. I should have said first, not single. Okay. Don't care about that right now. Care about that. So you say length is 27. I believe you. Length is 27. So the 11 bits labeled A contain the first subpacket, a literal value. This, I don't understand this rule. After the length type E and the 15 the subpackets appear. For example, The 11 bits labeled A contain the first subpacket, the literal value. So is that because this is 110, 100, oh, okay, so yeah, that's a subpacket. So all this is packet parsing, right? So obviously we want to parse packets. This is kind of, you know, parse a packet. I don't know what I want to return yet out of this. Ref and index. Parse packet for version. So let's do that. Well, actually, you can stay up there. Let's see, result plus equals parse packet, and return the result. Why are you upset? I don't know. Because I'm running still in the debugger? Is that why you're upset? Oh, parse packet for version. Okay. So if you're type 4, then we walk all of this, and then you get returned the results, right? Basically, we just walk the numbers and ignore them. So here, given this, we know that the length is 27, right? We know the length is 27, so we know we have to parse 27 bits worth of stuff. So our target index is index plus the length. So while index is less than the target index, we will just say result plus equals parse packet for version and ref index. All right. Then you can return your results. So this, now with our next set of data, should give us, throw new divide by 0, whatever, don't care. Argument out of length, 62. Okay, so when we come here the first time, our index should be 7. All right, because we did the first 6 and then we did 1 for the length type, so we're at 7. So this should be okay, right? Yeah, that's our length. So our length is 27, and then our index has moved forward 15. So our target index is now 49 because it's 22 plus 27. So when we pop in here, this should be, that's version 6, right? This is 110, so that's version 6. And our type is now 4. And our first bit is 0. We ignore that, and so then we break. And then we return the result. So our index is now 33. Okay. So our result now should be 6. 7. Oh, that's right, because we had one version, a version 1 and a version 6. So 33 still less than 49. Okay. This is probably a less than or equal to. Whatever. It'll be fine. So here we go again. So our next version is 2, right? 010, so that's version 2. Okay, so that's fine. So this should come out with 2 numbers, a number there and a number there. Oh, no, sorry. So that's version 2. Oh, this is type 1. Oh, I see. We have a type 1, which we haven't handled yet. That's why we rolled right over top. Oh, no, it's a type 4 again. Hang on. So our version is 2. Our type is 4. Okay, that's right. And then, so this is 5, and then this is 5. And so that should be enough, right? So our first bit is 1. And then our first bit is 0. So we can bail out. So our result now is 2. Okay, so our total now should be 9. Our index is 49. Our target index, yeah, so... Actually, less than was fine. Less than was correct. So we should bail out of this now. So this result should be 9. Now, index is 49. Data.length minus 6 is 50. 50. So data.length. So data 49 to the end, please. That's 7 zeros. 1, 2, 3, 4, 5, 6, 7 zeros, yeah. Well, then how am I supposed to know it's the end? So not part of transition should be ignored. So basically what I want is that's kind of weird. Like the end condition is if everything is 0. But the version doesn't say the version couldn't be 0, right? Does it? Next 3 bits. These 2 values are numbers. All numbers encoded. Well, version. Like, how am I supposed to know? It doesn't say that type has a limit. All right. So let's do this. If data length minus index is less than 8, and Let's see. Data subindex dot. Jeez. Dot all. That's all zeros. Then we should break. How about that? So that gets me version 9. So this is our... So here's our next example. This has got the other type. Bit labeled I as 1, the length type at 8, indicates that the length is an 11-bit number representing the number of subpackets. So basically, we don't know how long they are, we just know how many there are. Okay, so then that means packet count is going to be 11 bits. 11 bits. Well, packet count is greater than 0. Result plus equals a parsed packet per version for the index. Now we return the results. Suppose I could else this, and then else this, and then return the result. Exam length must refer to a location within the string. So this is now where? 44, but from 81, so here. Okay. So our version is 7, our type is 3, our length type is 1, so our packet count now is 3, which is what we expected. 11 bits labeled A contain the first subpacket, a literal. So our index is currently 18. Oh, I never decremented the packet count. That would help. Okay. So that gets us 14. For now, parse the hierarchy through the transmission and add up all the version numbers. So this is 16. Okay. And that is 12. Okay. That is 23. And that is 31. Okay. Here's my real data. It's a little bit longer. Okay. There's my first answer. We hope. Okay. Now that you have the structure of transmission decoded, you can calculate the value the expression represents. Literal values represent a single number as described above. The remaining type IDs are more interesting. Packets with type ID 0 are sum packets. Their value is the sum of the value of their subpackets. If they only have a single subpacket, their value is the value of subpacket. Packets of type 1 are product, 2 are minimum, 3 are maximum, 5 are greater than, 6 are less than, 7 are equal to. Value is 1 if the value of the first subpacket is equal to the value of the second subpacket. Using these rules, you can now work out the value of the outermost packet in your bits transmission. So we already know 4 was literal. So now what we need this to do is, instead of just returning the version, We also now need to return a result. And we'll call you now parse packet. All right, so for you, I need to extract the value now here, right? So the value is now convert to int32 data index to index plus 3 to, let's see, so this result should actually be version, and this should be result. Let's see, shoot, that was a bad name. Version total. Sure, we'll call you version total while we're here, right? Except that doesn't actually work. Result. So here we know that the result, result plus equals the value. Well, that's actually equal to the value, right? We want, wait a minute. Let me reread that, because now I don't remember exactly what this did. Literal packets encode a single binary value. Do this, the binary number is padded. Oh, so we just got to keep going. Right. First of all, can toInt64 do this? Appears to. Okay, so value text is a new string builder. All right, and then here what we want is value text plus equals this. All right. And then out here we want result to be this of the value text. And you don't do a plus equals here, you do an append. All right, so you are saying to me, let's go up here, right? So what you have to do would be 2021 in decimal. So everybody here needs to return version total, comma, results. Your return should go away. We're going to ignore you for a moment. Right. Let's go use our first sample again. So our value should be, whoops, we forgot to do this. Actually, this should come out here, because we only want to process this thing once, right? Let's see. We'll call you a version sum. And then we'll call you a value result sum, because that is what we're supposed to do, right? We're supposed to sum these together. If you get to evaluate the expression represented by your blah. Outermost packet. Oh, I see. Like, we're just supposed to get one value here, right? So here we want right? We just want to pop you out like that. No. RVR. You know, this whole thing here, like, it makes it sound like the whole thing is just one thing here. I'm wondering if that's actually true. All right, so if I do var version sum, comma, result is equal to parse packet of index, ref index. Right? And then you just return the version sum. And you just return the result. Right? Okay. So I get 6 and 250. 250 does not sound correct. 6 was okay, I think, right? 6. 3. All right, so programmer mode. Let's check their math, right? 0111, 1110, 0101. Oh, that's supposed to be in binary. Damn it. Try again. 0111, 1110, 0101. Decimal 2021. So did I get the wrong string? Is that what ended up here? Seems like I got the wrong string. Oh, yeah. I don't know how I got index plus 3 there. Should have been index plus 4. Okay. 2021, that looks okay. So this gets a version and a version and a result. It can just be called version. So I understand. So if your type is 4, this is you. Otherwise, these are your numbers. And I think what I end up having to do here is if I do var v r is equal to this, right? That's when I say version total plus equals v, version total plus equals v. And then I want the results. Results is a new list of longs. Alright, so then I come down here and I say var vr is this, version total plus equals v, and then results add r. Okay. So then, given the results, I just need to look at whatever the type is. All right, so let's do, this is sample 2. So we know sample 2 should, this is the 04. All right, so we've got other values here. So let's go start using some of these other things. I'll move you guys back down there. So you are the sum of 1 and 2. All right, so if I were to take a look at that, don't really care what your version total is. I'm trusting that that is correct. But the results... Yeah. I'll do switch. Let's say switch. What are you? Packet type? Type. Yeah, type. Switch type. So this is a sum. Sum is 0. Case 0. Result is results sum. Okay. So that should give me 3, right? Results? Nope, we never got there, did we? Type of 4. Oh, that's okay. We're doing the inner values, right? So our results list was 1 and 2, and so our result is 3. Result is results.sum. How is that not 3? Okay. The heck? Okay, I really don't understand how that's possible. Did this line of code just never run? Innumerable sum returned 3, but result never got the value. You know what? I got 3 here, so clearly this is the debugger being a jackass. Alright, so here's the rest of our cases, right? So product is case 1. So let's try this. So this should be 54. Result is results aggregate. We'll start with 1, and then total, and then we have total, and value is total times value. Break. Right. So that should be 54. Okay. Type 3 is minimum. Results min. 4 we know is results max. Oops, except that's not 4, that's 5. Pretty sure. 5. No, 3 is max. Oh, this is supposed to be 2. 3 is max. 5 are greater than packets. Their value is 1 if the value of the first subpacket is greater than the value of the second subpacket. Otherwise, their value is 0. So then we'll say result is results sub 0 greater than results sub 1. 1, otherwise 0. And 6 is less than. Value is 1 if the value of the first subpacket is less than the value. Otherwise, it's 0. That's less than, and then case 7 is equal to. Case 7 equal to 1, otherwise 0. Okay, so for input, this should be 9. This should be produces 1 because 5 is less than 15. This should produce 0 because 5 is greater than 15. 0 because 5 is not equal to 15. And 1 because 1 plus 3 equals 2 times 2. Okay. How bad could it be, right? Big giant number. Okay. See how I did? Actually, better than I expected, given how much trouble I had. Okay, first one in the small group. And looks like retaining my third place in the big group. Cool. All right, yeah, this one was a little weird. All right, let's delete all the test data, and then let's close all those. Is there a better way to do this? I honestly don't know. The interesting thing is, like, type 4, pretty much everybody in type 4, like, the only way you get values is type 4, right? Everybody else pulls values from type 4s that get embedded inside. It feels weird to have this so separate. But the rest of these are, you know, they are what they are, I guess. Yeah, I honestly don't see a whole lot to optimize here. So I guess this is going to be it. Excellent. Wow, that was a super fun amount of time, right? Okay, well, at least day 16 is done. So I'll see you all tomorrow.